Around 70,000 years ago, something happened that would change the planet forever. A small group of humans, maybe just a few hundred people, stood at the edge of the African continent and made a decision that seems absolutely insane when you think about it. They left. They walked away from the only world their species had ever known and ventured into lands where no human had ever set foot. They had no maps, no supplies, no idea what was waiting for them out there, and they never came back. Today, every person outside of Africa, all 7 billion of us scattered across 6 continents, carries the genetic signature of those original pioneers. We're all their descendants. The people watching this in Tokyo, in London, in Sao Paulo, in Sydney. Your ancestors were part of the greatest journey ever told, and here's the wild part. We're only just now figuring out what actually happened to them. If you're using this to fall asleep, that's exactly why I make these. So maybe subscribe, and definitely tell me where you are and what time it is right now. I check comments, and it's genuinely mind-blowing. Melbourne at morning coffee, Miami at midnight, Moscow at lunch. All at once. It's kind of perfect for a story about how humans spread everywhere. So what happened to those early humans who left Africa? The short answer is almost everything you can imagine, and plenty you can't. They faced Ice Age megafauna that would give you nightmares. They crossed landscapes so hostile that modern survival experts would refuse to attempt it. They met other species of humans, species we didn't even know existed until a few years ago, and somehow, impossibly, they survived it all. But this isn't just a story about survival, it's about transformation. Because the humans who left Africa 70,000 years ago weren't quite the same as us. Their brains were the same size, sure. They had language, probably. They made tools and controlled fire. But something changed during those millennia of migration. Something about facing the unknown, about adapting to radically different environments, about encountering other human species and either fighting them or breeding with them. All of it shaped us into what we are today. See, for most of the last 200,000 years, humans were an African species. We evolved there. We lived there. Our bodies were designed for African climates and African ecosystems. Then suddenly, within just a few tens of thousands of years, humans were living everywhere. In the frozen Arctic, where temperatures dropped to -40. In the tropical rainforests of Southeast Asia, where different diseases lurked in every water source. In the Australian outback, where virtually nothing about the environment matched what our African ancestors had known. How did that happen? How did a species adapted for the African savanna end up thriving in literally every climate zone on Earth except Antarctica? And what did it cost them? The discoveries scientists have made in just the last decade are genuinely shocking. We now know that those early humans who left Africa didn't just encounter harsh environments, they encountered other humans. Neanderthals in Europe and Western Asia, Denisovans in Eastern Asia, possibly other species we haven't even identified yet. And our ancestors didn't just fight these other humans, they had children with them. Today, if you're of European or Asian descent, somewhere between 1 and 4% of your DNA comes from Neanderthals. If you're of Melanesian or Aboriginal Australian descent, you're carrying Denisovan genes too. Think about that. You're not entirely Homo sapiens, you're a hybrid. We all are. The humans who left Africa mixed with other species so thoroughly that pure Homo sapiens basically don't exist anymore outside of sub-Saharan Africa. But genetic mixing is just the beginning of the story. The real magic is in the details of how these migrations actually happened. How did humans cross the Red Sea? Did they build boats or walk across land bridges that don't exist anymore? How did they survive in Central Asia during the last ice age when glaciers covered half of Eurasia? What did they eat? Where did they sleep? How did they protect their children? And here's the question that keeps anthropologists awake at night. Why did they keep going? Once you've made it out of Africa, once you've found a place with water and food and reasonable temperatures, why keep pushing into the unknown? What drives a species to keep migrating until they've literally reached the ends of the earth? Over the next few hours, we're going to follow those ancient footsteps. We'll start with the moment of departure, when small bands of humans made the terrifying decision to leave Africa. We'll track them as they spread across continents, adapting to new environments, meeting other human species, developing new technologies. We'll explore what daily life actually looked like for these Ice Age pioneers, and we'll see how their journey, their struggles, their victories and their defeats, how all of it echoes in our DNA and our cultures today. Because this isn't ancient history, this is your history. The story of how a small group of African migrants became everyone, everywhere. The story of what happened when humans left home and never looked back. So get comfortable. This is going to be a long journey. But then again, it took our ancestors 60,000 years to complete it. We've got time. So why did they leave? After hundreds of thousands of years in Africa, after surviving the bottleneck, after developing the tools and technologies that made them successful, why would a small group of modern humans decide to walk away from everything they knew and venture into the complete unknown? The answer isn't simple. It never is with human behavior. But around 70,000 years ago, a perfect storm of circumstances began pushing and pulling our ancestors toward the exits. First, there was climate change. And we're not talking about gradual warming or cooling over millennia. We're talking about dramatic, violent shifts that could transform landscapes within a single human lifetime. Around 74,000 years ago, Mount Toba in Indonesia eroded in what geologists call a supervolcanic eruption, the largest volcanic event in the past 2 million years. It ejected somewhere around 2,800 cubic kilometers of ash and rock into the atmosphere. To put that in perspective, the 1980 Mount St. Helens eruption ejected about 1 cubic kilometer. Toba was nearly 3,000 times more powerful. The ash cloud circled the globe, blocking sunlight for years, possibly decades. Global temperatures plummeted by as much as 10 degrees Celsius in some regions. In Africa, the climate shifted rapidly from relatively stable to brutally unpredictable. Droughts became more severe. Rainfall patterns changed. Plant and animal populations crashed. Genetic analysis of modern human population shows evidence of what scientists call a population bottleneck around this time. Not as severe as the one 900,000 years earlier, but significant. Human numbers may have dropped to as few as 10,000 individuals worldwide, maybe less. For populations living near the coasts or in regions with access to multiple food sources, this was survivable. Difficult, but survivable. But for groups in the interior, far from water sources, dependent on specific plant or animal species, it was catastrophic. This created pressure, not just to survive, but to move, to find new territories with untapped resources, to spread out so that a single local disaster couldn't wipe out an entire population. But pressure alone doesn't explain why modern humans succeeded in leaving Africa when earlier attempts had failed. Because this wasn't the first time Homo sapiens had tried to expand beyond the continent. There's archaeological evidence of modern humans in the Levant, the region that's now Israel, Lebanon and Syria, as early as 120,000 years ago. These early migrants established settlements, made tools, survived for thousands of years. Then they disappeared, completely replaced by Neanderthal populations moving south. So what was different about the migration that happened around 60,000 years ago? What had changed that allowed this attempt to succeed where earlier ones had failed? The answer is what paleoanthropologists call the cognitive revolution, and it might be the most important evolutionary development in human history. sometime between 100,000 and 70,000 years ago, something changed in the human brain. Not anatomically. Modern human skulls from 200,000 years ago are basically identical to skulls from 50,000 years ago. The change was neurological, behavioral, cognitive. Suddenly, the archaeological record explodes with evidence of complex symbolic thinking. Cave paintings appear in Africa, carefully crafted bone tools and jewellery, sophisticated weapons. Most importantly, evidence of long-distance trade networks, suggesting complex social relationships and communication. This is when humans started thinking abstractly at a level never seen before in any species. We began creating art not just for decoration, but to convey meaning. We developed complex language capable of discussing things that weren't immediately present. Past events, future plans, abstract concepts like kinship obligations and territorial boundaries. We started telling stories, and stories change everything. With language sophisticated enough to convey complex narratives, humans could share detailed knowledge about distant territories, safe routes, water sources, dangerous animals. They could maintain relationships with groups they hadn't seen in years. They could coordinate activities across vast distances and long time periods. This cognitive revolution gave the humans who left Africa around 60,000 years ago something their predecessors 60,000 years earlier hadn't possessed. A mental toolkit that made them not just adaptive, but actively innovative. Not just survivors, but explorers. When those earlier humans had encountered Neanderthals in the Levant, they were meeting a species that was physically superior and perfectly adapted to the local environment. The early modern humans had no particular advantage, so the Neanderthals, defending familiar territory with survival strategies refined over hundreds of thousands of years, won. But the humans who left Africa 60,000 years ago were different. They brought with them technologies and social structures that would prove decisive. So how did they get out? The traditional story says they walked. Across the Sinai Peninsula, the land bridge connecting Africa to Asia. And certainly some humans used that route. But genetic and archaeological evidence suggests the main migration happened somewhere else entirely. The Bab el-Mandeb Strait, the narrow channel of water separating the Horn of Africa from the Arabian Peninsula. Today it's about 20 miles wide at the narrowest point. Deep water, strong currents. Crossing it would require boats, navigation skills, serious planning. But 60,000 years ago, during the Ice Age, sea levels were much lower. Massive amounts of water were locked up in glaciers. The Bab el-Mandeb would have been only a few miles wide, possibly dotted with islands that could serve as stepping stones. This is the coastal migration theory. Instead of walking through the Sinai into the harsh deserts of the Middle East, the theory suggests modern humans crossed the Bab el-Mandeb and then followed the coastline eastward, along the shores of Arabia, Persia, India, Southeast Asia. Coastal routes have massive advantages: reliable access to water, abundant food sources from both land and sea, natural harbours and shelter, clear landmarks for navigation. For people who had spent hundreds of thousands of years living along the lakes and rivers of Africa, following coastlines would be intuitive. The problem with proving this theory is that most of those ancient coastlines are now underwater. Sea levels have risen over 300 feet since the Ice Age. The archaeological sites where those migrants would have lived are buried under hundreds of feet of ocean. But we found some evidence. Stone tools dated to around 55,000 years ago in Jebel Faya in the United Arab Emirates. Shell middens in Oman suggesting systematic seafood harvesting. Tool assemblages that look distinctly African rather than Middle Eastern, indicating these weren't Neanderthals but actual migrants from Africa. Most tellingly, genetic analysis of modern populations supports the coastal route. The oldest DNA lineages outside Africa show up first in Arabia, then along the coasts of South Asia and Southeast Asia, exactly the pattern you'd expect if people were following shorelines eastward. But whether they crossed at Bab el-Mandeb or walked through Sinai, one thing is clear: not many of them made the journey. Genetic analysis suggests the founding population of all non-African humans might have been as small as 1,000 individuals, maybe 10,000 at most. Think about that. Everyone alive today who isn't of purely African descent, all the Europeans, Asians, Native Americans, Pacific Islanders, all of us trace our ancestry back to a group of people who could have fit comfortably in a modern high school gymnasium. This makes sense from a migration perspective. Moving into unknown territory is risky. You don't send your whole tribe. You send scouts. Young people, probably. The adventurous ones. The ones with less to lose and more to gain from finding new hunting grounds. These pioneers would have been the best their communities had to offer. The best hunters. The most skilled tool makers. The boldest explorers. Natural selection doesn't just happen through death. It happens through who decides to take risks and who plays it safe. And what did they bring with them? What tools and knowledge did this small group carry as they stepped into a world no modern human had successfully colonized before? First, they had sophisticated stone tool technology. Not just simple hand axes, but carefully crafted blade tools made using prepared core techniques. Long, sharp cutting edges created by striking flakes off specially shaped stone cores. These blades could be hafted onto wooden or bone handles with plant resins, creating composite tools that were far more effective than anything their ancestors had possessed. They had throwing spears tipped with carefully shaped stone points. Not for thrusting at close range like Neanderthal spears, but for throwing from a distance using spear throwers, atlatls that could launch projectiles with deadly accuracy at ranges Neanderthals couldn't match. They carried fishing gear, bone hooks, possibly nets woven from plant fibres. The cognitive revolution had taught them to exploit aquatic resources systematically, not just occasionally. They knew how to make fire reliably. This sounds basic, but it's crucial. Earlier, humans could use fire if they found it, lightning strikes or natural fires. But modern humans could create it on demand using friction methods or striking sparks from pyrite. This meant they could venture into colder climates and survive. They could cook food, making nutrients more accessible and killing parasites. They could use fire to harden wooden tools, to drive game in hunts, to clear land. They had clothing. Not just animal skins thrown over shoulders, but fitted garments created with bone needles and sinew thread. The invention of the eyed needle, a tiny piece of carved bone or ivory with a hole for thread, might seem trivial, but it allowed humans to create cold weather clothing that could keep them alive in climates that would kill them in hours without protection. Most importantly, they had language. Complex, sophisticated language capable of conveying abstract ideas, sharing detailed technical knowledge, maintaining social relationships, telling stories that could preserve information across generations. This last point can't be overstated. Language is what allowed human knowledge to accumulate instead of being constantly rediscovered. A Neanderthal child had to learn everything from direct observation and practice. A modern human child could be told stories that conveyed the accumulated wisdom of dozens of generations. How to find water in the desert, which plants were poisonous, what weather signs meant rain was coming, where the herds migrated each season. Stories made humans capable of learning from people they'd never met, from ancestors who died before they were born. This is cultural evolution, and it operates on a completely different timescale than genetic evolution. Instead of taking thousands of generations to spread useful adaptations, modern humans could share innovations within a single generation. They also brought complex social structures, extended family networks that could maintain connections across hundreds of miles, marriage exchange systems that created alliances between groups, leadership hierarchies that could organize large-scale cooperative activities, trade relationships that moved valuable resources like high-quality stone for tools across vast distances. Archaeological sites from this period show evidence of these networks. You find stone tools in locations hundreds of miles from where the stone originated. You find seashells used as beads in inland sites far from any ocean. You find standardized tool designs across regions that must have shared technical knowledge through regular contact. These weren't just scattered bands of humans wandering randomly. This was a connected population capable of coordinating movement, sharing information, supporting each other across distances that would take weeks to walk. And they needed all of this because the world they were entering was already occupied, not by other modern humans, by their evolutionary cousins who had been living outside Africa for hundreds of thousands of years. Neanderthals controlled all of Europe and Western Asia. Denisovans dominated Eastern Asia. Both were perfectly adapted to their environments. Both had hundreds of thousands of years of local knowledge. Both were formidable competitors with resources. The early migrants from Africa wouldn't have known any of this. They were just looking for new hunting grounds, new territories where resources weren't already being exploited by competing groups. But they were walking into a world where they would have to compete with human species that had home field advantage. Early archaeological sites from the Arabian Peninsula show these pioneers' first steps. Jebel Fire, dated to around 127,000 years ago, shows one of the earlier attempts. Simple stone tools, similar to African designs, evidence of hunting and gathering, then nothing. The site was abandoned, possibly when climate conditions deteriorated. But sites from 60,000 years ago tell a different story. More sophisticated tools, evidence of longer occupation, signs that these migrants weren't just passing through, but establishing permanent presence. In the Levant, sites like Kafse and Skull Caves show modern human occupation around 100,000 years ago. These early migrants coexisted with Neanderthals for a while, maybe even traded or interacted. But eventually the modern humans disappeared, replaced by Neanderthal populations. The earlier cognitive revolution hadn't happened yet. These pioneers didn't have the technological or social advantages that would come later. But the migrants who left around 60,000 years ago were different. When they encountered Neanderthals in the Middle East, they brought tools and strategies that could compete. When they followed coastlines into Asia, they could exploit food sources Denisovans had overlooked. When they pushed into new territories, they could adapt faster than their evolutionary cousins because their culture was more flexible, their technology more innovative, their social structures more complex. The archaeological record shows their progress like breadcrumbs across the ancient world. Tools in Arabia by 55,000 years ago. Evidence in India by 50,000 years ago. Southeast Asia by 45,000 years ago. Australia, requiring sophisticated boat building and navigation by 42,000 years ago. They weren't moving as one massive migration wave. These were successive generations, each pushing a little further into new territories. A group would settle in one region for a few hundred years. Population would grow. Some of the young people would push further east or north or south. They'd establish new settlements. Their population would grow. The process would repeat. It was slow by our standards. The journey from Africa to Southeast Asia probably took 15,000 years. Generations of humans living and dying, each moving the boundary of human habitation just a little bit further. But it was relentless. Once started, the expansion never really stopped until modern humans had reached every habitable continent. They succeeded where earlier attempts had failed because they brought something genuinely new. Not bigger brains or stronger bodies. Neanderthals had them beat on both counts. They brought behavioural modernity. the complete package of cognitive abilities that made them capable of not just surviving in new environments, but thriving, innovating, constantly adapting. They brought the accumulated knowledge of hundreds of thousands of years of African survival strategies, refined during the crisis periods into adaptability itself. They brought stories that could teach lessons without individual experience. They brought social structures that could mobilize dozens or hundreds of people for coordinated activities. They brought technology that could be modified and improved with each generation, instead of remaining static for hundreds of thousands of years. When those 1,000 to 10,000 pioneers walked out of Africa, they were carrying the future of the human species with them. They didn't know it. They were just looking for better hunting grounds, more reliable water sources, territories that weren't already crowded with competing groups. But in their DNA, in their tools, in their stories and their social structures, they carried everything that would eventually allow modern humans to dominate the planet. The age of human global expansion had begun, and it would never really end until our species had left footprints on every continent and changed the face of the earth forever. The journey ahead would test them in ways they couldn't imagine. Frozen wastelands in Europe, high-altitude plateaus in Asia, ocean crossings to Australia, the long walk across Bringia into the Americas. Every environment Earth could throw at them, they would encounter and eventually master. But all of that was still ahead. For now, they were just a small group of humans following coastlines, eating shellfish and hunting unfamiliar game, slowly pushing eastward into a world that had never seen their like before. The greatest journey in human history had begun. Then came the meeting that would decide the fate of humanity. Around 60,000 years ago, a small group of modern humans finally left Africa. Not the whole population, just maybe a few hundred individuals who crossed the narrow waters between the Horn of Africa and the Arabian Peninsula. They were looking for new territories, following animal migrations, perhaps fleeing conflict or drought. They had no idea they were about to encounter cousins they'd never known existed. For over 400,000 years, three human species had been evolving in complete isolation from each other. Modern humans had remained in Africa, developing the behavioral flexibility and technological innovation that would become their signature traits. Neanderthals had been perfecting survival strategies for Ice Age Europe, becoming stocky, powerful hunters adapted to brutal cold, and the Denisovans, mysterious and still mostly unknown, had spread across Asia, adapting to everything from tropical islands to mountain plateaus. Now, for the first time since the post-bottleneck split, these evolutionary cousins were about to come face to face. The first encounter probably happened somewhere in the Levant, the region we now call the Middle East. Modern humans pushing north from Africa would have encountered Neanderthals at the southern edge of their range, somewhere near modern-day Israel or Lebanon. Archaeological evidence shows both species using the same caves, sometimes separated by only a few thousand years, sometimes overlapping. Imagine that moment. You're a modern human scout, exploring territories your people have never seen before. Your band has been travelling for weeks following the coast, hunting unfamiliar animals, testing strange plants. Then one morning, across a valley, you see smoke from a fire, other humans. But when you get closer, something's wrong. They're human, absolutely, but different. Shorter than your people, but massively built. Shoulders like boulders. Faces that project forward with enormous brow ridges and nasal openings you could fit your thumb into. Skin probably lighter than yours, adapted to less intense sunlight. Hair possibly red or blonde, colours you've never seen on a human before. Their clothing is simple, animal hides, but expertly tailored. Their spears are thick and powerful, designed for close-range thrusting rather than throwing. These are Neanderthals, your evolutionary cousins, separated for 400,000 years, but still recognisably human. What happened next is written in our DNA, and the story it tells is more complex and fascinating than anyone imagined until very recently. In 2010, a team led by Svante Pääbo at the Max Planck Institute achieved something incredible. They sequenced the entire Neanderthal genome from ancient bones, and when they compared it to modern human DNA, they found something nobody expected. Everyone of non-African descent carries Neanderthal DNA. About 1 to 4% of the genome spread throughout our chromosomes, proof positive that our ancestors didn't just encounter Neanderthals, they interbred with them. This was revolutionary. For decades, the prevailing theory had been that modern humans and Neanderthals were separate species that competed for resources but never interbred. The DNA evidence shattered that assumption completely. Not only did we interbreed, we did it multiple times over tens of thousands of years. The genetic signatures show at least 3 major episodes of interbreeding, probably more, whenever and wherever the two species ranges overlapped. But here's what's really remarkable. This interbreeding was successful. The hybrid offspring weren't sterile like mules. They could reproduce, and they passed Neanderthal genes down through generations all the way to the present day. Every non-African person alive today carries genetic variants that originated in Neanderthal populations over 50,000 years ago. Some of those variants turned out to be incredibly useful. Neanderthals have been living in Eurasia for hundreds of thousands of years, dealing with diseases and pathogens that African populations had never encountered. When modern humans interbred with Neanderthals, they acquired immune system genes that provided resistance to local diseases. Genetic analysis shows that many of the Neanderthal variants that persist in modern populations are related to immune function. They gave our ancestors a survival advantage, a kind of rapid-acting genetic inoculation against Eurasian diseases that would otherwise have devastated migrating populations. Other Neanderthal genes helped with skin and hair. Modern humans evolved in tropical Africa with dark skin optimized for intense sunlight. Moving into higher latitudes with less UV radiation, lighter skin became advantageous for vitamin D production. Some of the genes controlling skin and hair color in modern Europeans came from Neanderthals, who'd already adapted to these conditions. But the story gets even more interesting when we look at the other species modern humans encountered, the Denisovans. The Denisovans are one of the most mysterious human species we know of. Unlike Neanderthals, who left thousands of fossils across Europe and Western Asia, Denisovans are known from just a handful of bone fragments. A finger bone found in Denisova cave in Siberia, a jaw discovered by a monk in Tibet, a few teeth and skull fragments scattered across Asia. If we only had the fossils, we'd barely know they existed. But then scientists extracted DNA from that finger bone, and suddenly an entire lost species emerged from the shadows. The Denisovan genome revealed they were a sister species to Neanderthals, having split from a common ancestor about 400,000 years ago. But while Neanderthals stayed in Europe and Western Asia, Denisovans spread across the entire Asian continent, from Siberia to Southeast Asia, from high-altitude plateaus to tropical islands. They were incredibly successful, occupying a vast range of environments, adapting to extreme conditions that modern humans would struggle with even today. And just like with Neanderthals, modern humans interbred with them. The genetic evidence shows multiple encounters across Asia. When modern humans pushed east from the Middle East around 50,000 years ago, they met Denisovan populations and formed relationships with them. Today, people across Asia carry Denisovan DNA, usually around 0.2% of the genome. But some populations have much more. Modern Papuans and Aboriginal Australians carry up to 6% Denisovan ancestry, the highest levels of archaic human DNA found in any modern population. This tells us that the interbreeding wasn't just a one-time thing. It happened repeatedly, in multiple locations over thousands of years. Modern humans moving through Southeast Asia encountered different Denisovan populations and interbred with each one. The genetic signatures show at least 3 separate Denisovan lineages contributed DNA to modern humans. 3 distinct populations, probably separated from each other by thousands of miles and tens of thousands of years, all encountering and interbreeding with our ancestors, and some of those Denisovan genes provided spectacular survival advantages. The most famous example is the EPAS1 gene variant found in modern Tibetans and other high-altitude populations. This gene affects how the body processes oxygen. At high altitudes where oxygen is scarce, most people develop altitude sickness. Their blood thickens with extra red blood cells, putting strain on the heart and causing serious health problems. But people with the Denisovan EPAS1 variant don't have this problem. Their bodies regulate oxygen more efficiently, allowing them to live comfortably at altitudes that would incapacitate others. This gene came directly from Denisovans. Genetic analysis shows the Denisovan population that contributed this variant was living on the Tibetan plateau, probably for hundreds of thousands of years, long enough for natural selection to create this remarkable adaptation. When modern humans arrived and interbred with them, they acquired in a single generation an adaptation that would have taken hundreds of thousands of years to evolve naturally. Other Denisovan genes seem to have helped with immune function in tropical environments, resistance to specific parasites, and metabolism of certain foods. Just like the Neanderthal genes, these weren't genetic junk. They were tested, proven survival adaptations that modern humans acquired through interbreeding. But here's the question that haunts this story. If interbreeding was happening, if relationships were forming, if hybrid children were being born and thriving, why did Neanderthals and Denisovans eventually go extinct? The answer isn't simple. It definitely wasn't genocide. The genetic evidence would look very different if modern humans had simply killed off their evolutionary cousins. What we see instead is a long, complex process of interaction, competition, and gradual displacement that played out over tens of thousands of years. In the Middle East, the first contact zone, control of the region shifted back and forth repeatedly. Climate would change, and Neanderthals would push south into areas modern humans had occupied. Then conditions would shift again, and modern humans would expand north. Archaeological evidence shows caves being occupied alternately by different species, sometimes with gaps of only a few centuries between occupations. Neither species could establish permanent dominance until modern humans developed what archaeologists call the Upper Paleolithic toolkit around 45,000 years ago. This was a technological revolution, sophisticated spear throwers that could kill from 30 meters away, bone needles allowing fitted, insulated clothing for extreme cold, fishing hooks and nets opening up aquatic food sources, systematic blade production creating long, sharp cutting edges from minimal stone. These weren't just better tools, they were force multipliers that changed the competitive equation completely. A Neanderthal hunting party needed to get close to prey, using heavy thrusting spears that required tremendous strength and courage. Dangerous work with high injury rates. A modern human group with spear throwers could kill the same animal from a safe distance with less risk and fewer people. This efficiency advantage compounded over time. Smaller groups could control larger territories. Fewer hunting accidents meant faster population growth. Better cold weather clothing allowed expansion into regions Neanderthals found challenging. Slowly, steadily, Neanderthal populations began shrinking. First, they lost the prime hunting grounds, the river valleys and coastal plains with abundant game. Then they were pushed into more marginal territories, mountain valleys, and northern forests. By 40,000 years ago, Neanderthal populations in Western Europe were fragmenting into isolated pockets. By 35,000 years ago, they controlled only scattered refuges in southern Europe. The last known Neanderthals lived in Gibraltar around 28,000 years ago, isolated on a peninsula at Europe's southern edge, a remnant population clinging to existence in an ever-shrinking refuge. Then they were gone, not killed off in some dramatic final battle, but simply outcompeted, generation by generation, for resources in a world that was filling up with a more technologically advanced species. The Denisovan story followed similar patterns, but played out differently across Asia's vast landscapes. The continent was large enough and diverse enough that different human species could occupy separate ecological niches for longer periods. Denisovans adapted to high mountains continued living there even as modern humans occupied the valleys. Denisovan populations that had become seafaring specialists maintained control of island chains. But eventually the same demographic and technological pressures that eliminated Neanderthals affected Denisovans too. Modern humans could support larger populations in the same territories. They innovated faster, developing new technologies every few thousand years, while Denisovans, like Neanderthals, tended toward technological conservatism. They could exploit a wider range of food sources, making them less vulnerable to environmental changes. The genetic evidence suggests some Denisovan populations survived surprisingly late. There are hints of interbreeding events in Southeast Asia as recently as 25,000 years ago, long after Neanderthals had disappeared from Europe. But one by one, Denisovan populations were absorbed through interbreeding, displaced by expanding modern human populations, or simply went extinct as their numbers dwindled below viable levels. By 20,000 years ago, Homo sapiens were the only human species left standing. But we weren't quite alone. Recent discoveries have revealed the picture was even more complex than we thought. In 2003, archaeologists discovered fossils on the Indonesian island of Flores that didn't fit any known human species. Homo floresiensis, nicknamed the Hobbit, stood only about a metre tall with a brain 1/3 the size of modern humans. Yet they made sophisticated tools and hunted successfully until at least 50,000 years ago, right when modern humans were arriving in the region. In 2019, another mysterious human species emerged from cave deposits in the Philippines. Homo luzonensis, known from a handful of bones, showed a bizarre mix of primitive and advanced features. They had curved finger bones suggesting they still climbed trees regularly, but they also made stone tools and successfully colonized an island that required water crossings to reach. The genetic evidence hints at even more unknown species. DNA analysis of modern Asian populations shows traces of ghost lineages, genetic variants that don't match any known human species. These might be from Denisovan populations we haven't discovered yet, or they might represent entirely unknown species that interbred with our ancestors and then vanished. What all this tells us is that the human family tree during the late Pleistocene was far bushier than anyone imagined even 20 years ago. Modern humans emerging from Africa around 60,000 years ago entered a world that was full of other human species. Some we've discovered and named, others we know only from genetic shadows. Some we probably haven't found yet, and our ancestors encountered them, interacted with them, formed relationships with them, and sometimes had children with them. This wasn't conquest or genocide. It was something more complex, competition mixed with cooperation, displacement mixed with integration. A long, gradual process where one species, through a combination of technological innovation, demographic advantage, and behavioral flexibility, slowly came to dominate while the others faded away. But those other species didn't disappear completely. They live on in us. That Neanderthal DNA helping your immune system fight off infections. Those Denisovan genes helping Tibetans live at extreme altitudes. Unknown variants from unnamed species hidden in our genomes still doing their jobs after tens of thousands of years. The question of why modern humans succeeded where our cousins failed brings us back once again to the bottleneck. All three post-bottleneck species, modern humans, Neanderthals and Denisovans, inherited the same genetic toolkit from those taxon 280 survivors. Intelligence, cooperation, technological innovation, adaptability. All three species had these traits. But modern humans had one crucial advantage. The African population that gave rise to Homo sapiens had faced ongoing environmental instability even after the worst of the bottleneck crisis ended. While Neanderthals adapted to the relatively predictable patterns of Ice Age Europe, and Denisovans specialized for specific Asian environments, modern humans had been selected for maximum flexibility. Constant climate shifts, unpredictable rainfall, animal populations that appeared and disappeared. All this kept African populations evolutionarily loose, never locked into rigid specializations. When the three species finally encountered each other, Neanderthals and Denisovans were like highly specialized tools, incredibly effective under the right conditions but difficult to adapt for new purposes. Modern humans were more like a Swiss Army knife, not perfectly optimized for any single task, but capable of handling whatever challenges arose. This flexibility showed up everywhere. Technology that innovated constantly. Social networks that could scale up rapidly when needed. Demographic patterns that allowed faster population growth. Communication abilities that could coordinate larger groups across greater distances. Dietary flexibility that made modern humans almost impossible to starve out. The encounters between modern humans and our archaic cousins weren't predetermined victories. For thousands of years, the outcome was uncertain. Neanderthals were stronger, better adapted to cold, and had been successfully surviving Ice Age conditions for over 200,000 years. Denisovans controlled vast territories and had their own sophisticated adaptations. Any of them might have won the competition. But in the end, behavioral flexibility trumped physical specialization. Rapid innovation beat technological conservatism. And the species that could adapt to anything gradually replaced the species that were perfectly adapted to specific things. By 15,000 years ago, the age of multiple human species was over. Only we remained, carrying genetic fragments of our vanished cousins, spreading to every corner of the planet. The first encounters had decided our fate, and the answer had been written in our DNA 900,000 years earlier, when a tiny population of survivors emerged from the worst crisis in human history, carrying the genes that would eventually allow their descendants to inherit the Earth. Once modern humans left Africa around 60,000 years ago, they weren't just wandering aimlessly into unknown territory. They were conquering it, step by step, generation by generation, adapting to environments their ancestors could never have imagined. And the speed at which they did it is nothing short of remarkable. The first major stop was the Middle East. Archaeological sites like Skul and Kafse in what is now Israel show us that modern humans had established themselves in this region by at least 50,000 years ago. Maybe earlier. These weren't temporary camps. These were proper settlements, places where people lived for generations, raised families, buried their dead with care and ceremony. The Middle East during this period was actually pretty hospitable. Temperate climate, abundant game, access to both Mediterranean and inland resources. It was the perfect staging ground, a place where African migrants could pause, multiply, and prepare for the next phase of their expansion. But they weren't just resting. They were adapting, learning, innovating. The sites show something fascinating. These early Middle Eastern populations were already developing new technologies that their African ancestors hadn't needed. More sophisticated projectile weapons for hunting larger prey. better techniques for processing plant foods from temperate species that didn't exist in Africa. And most importantly, they were figuring out how to make clothing. This might not sound revolutionary, but think about it. In Africa, you don't really need clothes. Maybe some basic covering for protection or decoration, but not insulation. The Middle East, though, has actual winters, temperatures that drop below freezing, conditions where exposed skin becomes a liability rather than an asset for heat regulation. So they learned to sew. Archaeological evidence from this period shows bone needles, carefully crafted with tiny eyes for threading sinew through leather and fur. This is sophisticated tailoring, planned manufacturing of fitted garments that could keep you warm in conditions that would kill an unprotected human in hours. And they would need those skills, because some of them were about to head north into conditions that made Middle Eastern winters look tropical. Around 45,000 years ago, modern humans began pushing into Europe, and this was Europe during the last ice age. Not the comfortable, forested continent we know today. This was a landscape dominated by tundra and grassland, massive glaciers covering Scandinavia and pushing south into what is now Germany and Poland, winters that lasted 8 months or more, summers that were brief, intense, and unpredictable. This was Neanderthal territory. And the Neanderthals, remember, had been living here for hundreds of thousands of years. They knew every cave, every migration route of every prey species, every place where flint could be quarried and water found during the frozen months. They were the masters of Ice Age Europe. And yet, within just a few thousand years, modern humans had not only established themselves here, they had created something entirely new, something archaeologists call the Aurignacian culture. The Aurignacian sites are unlike anything that came before them. We're talking about the oldest sophisticated art in Europe, cave paintings at Chauvet in France, dating to about 37,000 years ago, showing horses, lions, rhinoceros, rendered with stunning detail and artistic skill. These weren't crude scratches. These were compositions, planned artworks that required multiple sessions, scaffolding to reach high cave walls, and most importantly, leisure time. You don't create art when you're barely surviving. Art emerges when a society has become efficient enough at meeting basic needs that people can devote time and energy to symbolic expression. The Aurignacian people weren't just surviving in Ice Age Europe, they were thriving. Their toolkit was revolutionary. Blade technology far more advanced than anything Neanderthals had developed. Bone and antler tools carved into specialized implements for specific tasks. Spear throwers, devices that could launch projectiles with 3 times the force of a hand-thrown spear. This was military-grade weaponry by Stone Age standards. But the most impressive adaptations were physical. The human body itself was changing in response to the new environment, and we can track these changes in the skeletal remains and genetic evidence left behind. Skin color shifted dramatically. In Africa, dark skin protects against intense UV radiation. It's a crucial adaptation for preventing skin cancer and protecting folate, a nutrient essential for reproduction. But in northern latitudes, especially during Ice Age conditions with limited sunlight, dark skin becomes a liability. You need UV exposure to produce vitamin D, and without it, you get rickets, weakened bones, all sorts of health problems that reduce survival and reproduction rates. So natural selection favoured lighter skin. Not instantly, evolution doesn't work that fast, but over hundreds of generations, European populations became progressively paler as individuals with genetic variants for lighter skin had more surviving children. By 20,000 years ago, Ice Age Europeans probably had skin tones similar to modern Northern Europeans. Body proportions changed too. The tall, slender build that's ideal for heat dissipation in Africa becomes a disadvantage in extreme cold. You want a compact body with shorter limbs, reducing surface area relative to volume. Less surface area means less heat loss. Natural selection favoured stockier builds in northern populations. We can see this in the skeletal remains. Early modern humans in Europe show progressively shorter, more robust proportions the longer they lived in cold climates. Not Neanderthal-level robustness, but definitely more compact than their African ancestors. And there were metabolic changes we can only detect through genetic analysis. Variants that affected how the body processed fats, crucial for surviving on a high-protein, high-fat diet dominated by large game. Adaptations in genes related to cold tolerance and energy metabolism. Changes in immune system genes, responding to new pathogens encountered in Eurasia. The human body was being resculpted by natural selection to match its new environment. But cultural adaptations were happening even faster than biological ones. Shelter construction became critical. In Africa, you can sleep under a tree or in a simple lean-to most of the year. In Ice Age Europe, inadequate shelter means death. So they built sophisticated dwellings, mammoth bone huts, using the massive skulls and long bones as structural supports, covered with hides and turf for insulation. Semi-subterranean pit houses, dug into the ground for thermal mass and protection from wind. Some sites show evidence of hearths designed to maximize heat retention and minimize smoke. These weren't crude camps. These were engineered structures that required planning, cooperation, and technical knowledge passed down through generations. At the same time, other groups were heading east across Asia. And this was a completely different kind of adaptation challenge. The Asian expansion followed two main routes. Some groups moved north through Central Asia, following river systems like the Ob and Yenisei into Siberia. Others moved south and east, following coastlines through India, Southeast Asia, eventually reaching Indonesia and beyond. The coastal route was probably easier, at least initially. Coastlines provided consistent resources, shellfish, fish, seabirds, marine mammals. You could keep moving east following the shore, never straying too far from food and water. Archaeological evidence suggests these coastal migrants moved fast, from the Middle East to Southeast Asia in maybe 10,000 years. That's covering 8,000 miles in 400 generations. Not a leisurely stroll, but not a desperate flight either. A steady expansion, each generation pushing a little further, establishing new settlements, sending out exploratory parties that sometimes founded new colonies, and sometimes returned with information about what lay ahead. But this journey required its own adaptations. Different diseases, different parasites, different food sources. Tropical conditions in Southeast Asia were nothing like Ice Age Europe. High heat and humidity instead of bitter cold. Dense forests instead of open tundra. Completely different animal species. So body types adapted differently here, maintaining the taller, slender builds that worked well for heat dissipation, developing resistance to tropical diseases, adapting to diets heavy in starchy plants and seafood rather than large mammals, and they were innovating technologically in unique ways. Evidence suggests these Southeast Asian populations developed sophisticated boat-building skills far earlier than their European cousins. You can't reach many of the islands in Indonesia and the Philippines by accident. You need boats capable of open water voyaging, planning expeditions, navigation techniques that let you return home. Some researchers think these coastal populations developed the first true maritime cultures. People who spent as much time on water as on land. Communities that built their entire survival strategy around ocean resources. The northern route through Central Asia was harder. Colder conditions, less predictable resources. But those who took this path eventually became the ancestors of Native Americans, the people who had crossed the Bering Land Bridge into an entire hemisphere of new territory. We'll get to that story. For now, what matters is that they survived conditions almost as harsh as Ice Age Europe, while maintaining the ability to keep moving east. Then there's the Ust-Ishim individual, one of the most important fossil discoveries in human evolution, found in western Siberia, dating to about 45,000 years ago. Just a single thigh bone, but the DNA preserved in it tells an incredible story. This person, and we know it was a man from the genetic analysis, lived during the earliest phase of the Eurasian expansion. His genome shows he was more closely related to both ancient Europeans and ancient Asians than either group is to each other. That means he lived before those populations had fully diverged. He represents a time when the expanding modern human population hadn't yet split into distinct regional groups. But here's what's remarkable. He was already living in western Siberia 45,000 years ago. This is just a few thousand years after modern humans first left Africa. The speed of this expansion is breathtaking. His ancestors had left tropical Africa, crossed the Middle East, and pushed deep into one of the coldest inhabited regions on Earth in maybe 200 generations. And the Ust-Ishim man wasn't some struggling pioneer barely hanging on. His bones show he was healthy, well-nourished. His DNA contains Neanderthal ancestry, about 2%, roughly the same as modern non-Africans. But interestingly, his Neanderthal segments are longer than those in modern populations. This tells geneticists that his Neanderthal ancestry was more recent than ours. He lived closer in time to the actual interbreeding events. He's a snapshot of humanity in transition. No longer purely African, not yet fully adapted to Eurasian conditions. A person caught between worlds, carrying the genetic legacy of multiple species, adapting in real time to one of the harshest environments humans had ever attempted to inhabit. Further west, the Kostenki sites in Russia tell another crucial part of this story. A cluster of archaeological sites along the Don River, occupied repeatedly between 45,000 and 30,000 years ago. These represent some of the earliest modern human settlements in Europe proper, not the Middle Eastern fringe, but deep in the continental interior. And what's fascinating about Kostenki is the sophistication of the remains. We're talking about structures 65 feet long, made from mammoth bones and wood, with multiple hearths suggesting communal living spaces, storage pits containing thousands of stone tools, evidence of long-term planning and resource management, ornaments made from shells that came from the Black Sea 300 miles away, proof of trade networks stretching across vast distances. The people at Kostenki weren't just surviving. They had created a stable, prosperous society in conditions that would challenge modern humans equipped with contemporary technology, and they did it with stone tools, animal hide clothing, and knowledge passed down orally through generations. But then came the ultimate test. Around 26,000 years ago, the climate took another turn for the worse. The last glacial maximum, the coldest, driest period of the entire Ice Age. Global temperatures dropped 10 to 15 degrees Fahrenheit below modern levels. Glaciers advanced across Europe and Asia, covering landscapes that humans had been living in for thousands of years. Sea levels dropped 400 feet as water got locked up in ice sheets. Britain became connected to continental Europe. Indonesia was part of mainland Asia. You could have walked from France to Ireland without getting your feet wet. For human populations, this was a crisis approaching the severity of the ancient bottleneck. Not as sudden, not as total, but devastating nonetheless. Large areas that had supported human populations became uninhabitable. Groups were forced south into refuge zones. Spain and southern France in Europe, the Black Sea coast, Southeast Asia. Populations that had been growing and expanding for 20,000 years were suddenly compressed into shrinking territories. But they survived. because all those adaptations, cultural and biological, that they had been developing paid off during this crisis. The clothing technology that had been refined over thousands of years let them endure temperatures that would kill an unprotected human in minutes. Layered garments made from fur and leather, sewn with sinew thread using bone needles, insulated footwear, protective headgear. This was sophisticated cold weather gear that wouldn't have looked out of place on a modern Arctic expedition. The shelter construction techniques they had mastered meant they could build dwellings that retained heat even when the outside temperature dropped to -40. The hearth designs that directed heat where it was needed and evacuated smoke efficiently. The semi-subterranean construction that used the earth itself for insulation. The food storage and preservation methods they had developed, using natural refrigeration in permafrost, drying and smoking meat, processing plant foods in ways that extended their shelf life. These techniques let them survive the long winters when hunting was nearly impossible, and plant foods were completely unavailable, and most importantly the social networks they had created. During the glacial maximum, survival wasn't about individual families toughing it out alone. It was about communities supporting each other, trade networks sharing resources when local conditions failed, knowledge being passed between groups about which areas still had game, where water could be found, how to adapt techniques that worked in one refuge zone to conditions in another. The genetic evidence from this period shows something remarkable. Despite being compressed into these refuge zones, despite population crashes that might have reduced total numbers by 60 or 70%, humans maintain genetic diversity better than might be expected. This suggests the social networks were functioning. Populations that might have been isolated weren't. People were moving between refuge zones, maintaining contact, exchanging marriage partners. The bottleneck 900,000 years earlier had taught humanity a lesson about what happens when populations become isolated. These survivors of that crisis had been the ones who could cooperate, who could share knowledge and resources. Those lessons, encoded culturally if not genetically, were still guiding human behavior hundreds of thousands of years later. By 19,000 years ago, the worst was over. Temperatures began to rise, the glaciers retreated, sea levels came up, and the human populations that had sheltered in refuge zones began expanding again, back into the territories their ancestors had abandoned, and into new lands that had never seen human footprints. They emerged from the glacial maximum fundamentally changed. The technological innovations developed during the crisis, better tools, better clothing, better social organization, these didn't disappear when conditions improved. They became part of the standard human toolkit, the adaptations, both physical and cultural, that had allowed survival in the harshest conditions now made humans incredibly efficient at exploiting any environment. The stage was set for the final phase of human expansion, the colonization of the last uninhabited continents, and the transformation from nomadic hunter-gatherers into the agricultural civilizations that would eventually dominate the planet. But we're getting ahead of ourselves, because there's still an incredible story to tell about how humans reached the most remote and challenging environments on Earth. Islands in the Pacific that required sophisticated navigation. The Americas, empty of human presence, waiting to be discovered. Even the harsh deserts and high mountains that seemed utterly inhospitable to life. That journey from the frozen refuges of the last glacial maximum to every corner of the planet is what comes next. And it's every bit as remarkable as the adaptation to Ice Age Europe and tropical Asia. Because humans weren't done adapting yet, not by a long shot. While modern humans were encountering Neanderthals in the Middle East and Denisovans in Asia, some groups were pushing even further. Not content with colonizing familiar environments, they were about to attempt something unprecedented in the history of life on Earth. They were going to cross open ocean. Around 65,000 years ago, maybe as early as 70,000, a small group of modern humans stood on the shores of Southeast Asia, staring across the water at a land that no human had ever seen. Australia. Even during the Ice Age, when sea levels were much lower and many land masses were connected, Australia remained isolated. There was no land bridge, no continuous coastline to follow. Getting there would require crossing at least 60 miles of open water, possibly much more depending on the route. This wasn't something you could stumble into accidentally. You couldn't just wade out too far and find yourself on a new continent. These people had to deliberately build watercraft capable of surviving ocean crossings. They had to bring enough food and water to last days, maybe weeks. They had to navigate using only the sun, stars, and an understanding of wind and currents that must have taken generations to develop. And they had to make this journey knowing they might never return. That's the thing that strikes you when you really think about what they were attempting. This wasn't exploration in the modern sense, sailing ships out and bringing them back to report your findings. The boats they built from bamboo, logs, or animal skins weren't designed for return voyages. These were one-way tickets. Once you left Southeast Asia and reached Australia, you were there for good. You and your descendants would have to survive in a completely unknown environment, with only the tools and knowledge you brought with you. Why would anyone take such a risk? We'll never know for certain, but the genetic bottleneck provides some clues. Those 117,000 years of near extinction had selected for something unusual in human populations. A willingness, maybe even a compulsion to explore, to push boundaries, to see what was beyond the horizon. The populations that survived the bottleneck weren't the ones that stayed safely in known territories. They were the risk-takers, the innovators, the groups willing to try new food sources, new territories, new survival strategies when the old ones failed. That genetic legacy was still driving human behavior 800,000 years later. So they built their boats and they sailed. The archaeological evidence from Australia tells us they succeeded. Multiple sites across the continent show human occupation dating back at least 65,000 years, possibly older. These weren't just coastal settlements either. Within a few thousand years of arrival, humans had spread throughout the entire continent, from the tropical north to the temperate south, from coastal regions to the arid interior. This was an environment like nothing they had ever encountered. Australia's megafauna, the giant animals that had evolved in isolation for millions of years, had never seen human predators before. Kangaroos the size of horses, wombats as large as cars, massive flightless birds called genyornis, land-dwelling crocodiles, marsupial lions with bolt-cutter jaws powerful enough to crack bone, all of them completely naive to the hunting strategies modern humans had spent hundreds of thousands of years perfecting. The new arrivals also brought something Australia had never experienced before: fire, used systematically as a landscape management tool. Aboriginal Australians developed what archaeologists call fire stick farming, deliberately burning vegetation to create hunting grounds and encourage the growth of useful plants. This wasn't random destruction. It was sophisticated environmental engineering based on deep understanding of Australian ecology, but it had consequences. Within about 10,000 years of human arrival, most of Australia's megafauna went extinct. The debate about why still rages among scientists. Was it hunting, climate change, habitat disruption from fire stick farming? Probably all three compounding each other. But the timing is hard to ignore. For millions of years, these animals had survived climate fluctuations, droughts, and floods. Then humans arrived, and within a geological eye blink, they were gone. The Aboriginal Australians didn't disappear, though. They thrived. Isolated from populations in Asia and elsewhere, they developed one of the longest continuous cultures in human history. Their technological toolkit remained relatively simple by Eurasian standards, but that's because it didn't need to be complex. They had perfected survival strategies that worked brilliantly in Australian conditions. Complex kinship systems governed social relationships across hundreds of miles. Songlines, mental maps encoded in oral tradition, allowed people to navigate vast distances across seemingly featureless terrain. They developed over 250 distinct languages and maintained knowledge systems that preserved detailed ecological information for thousands of years. All of this from that initial group of maybe a few hundred people who dared to cross open ocean to reach an unknown land. But they weren't done exploring, not by a long shot. Around the same time humans were settling Australia, other groups were pushing north and east into the Pacific. This was an even more audacious undertaking than reaching Australia. The Pacific Ocean is vast, mind-bendingly vast. 36 Africas could fit inside it, and scattered across this enormous expanse are tens of thousands of islands, most of them tiny specks of land separated by hundreds or thousands of miles of empty ocean. The earliest Pacific Islanders weren't trying to reach specific destinations. They couldn't have known those destinations existed. They were island hopping, pushing gradually further from the Asian mainland, establishing populations on increasingly remote islands. Each successful voyage required sophisticated maritime technology. Double-hulled canoes that could carry people, supplies, and breeding pairs of animals and plants. Navigation techniques that used wave patterns, bird behavior, and celestial observations to find land beyond the horizon. Social organization capable of mounting expeditions requiring dozens of people and months of preparation. And it required something else, an almost incomprehensible tolerance for risk. Modern computer simulations have tried to calculate the odds of successfully reaching remote Pacific islands using prehistoric navigation techniques. The results are sobering. Many voyages would have failed. Boats would have missed their targets by miles and sailed into empty ocean until everyone aboard died of thirst. Others would have been swamped by storms or driven onto reefs. But some succeeded, and that was enough. By 50,000 years ago, humans had reached New Guinea. By 30,000 years ago, they had settled islands in the Bismarck Archipelago and the Solomon Islands. These early Pacific Islanders encountered and interbred with Denisovan populations already living in the region, which is why modern Pacific Islanders carry the highest percentages of Denisovan DNA found in any living population, up to 6% in some groups. The settlement of the remote Pacific would continue for tens of thousands of years. Fiji was reached about 3,500 years ago, Hawaii about 1,500 years ago. New Zealand, the last major landmass to be permanently settled by humans, was colonized only about 800 years ago. Each successful voyage represented a triumph of human ingenuity, courage, and that same restless drive to explore that had been selected for during the bottleneck. While some human populations were learning to navigate the Pacific, others were preparing to cross into an entirely new hemisphere, North and South America. The Western Hemisphere had never seen human footprints. For over 3 million years, while human ancestors had been evolving in Africa and spreading across Europe and Asia, the Americas had developed their own unique ecosystems in complete isolation. Getting there would require crossing from Asia into Alaska, which sounds simple enough, except that between Asia and Alaska lies the Bering Strait. Today, it's about 50 miles of cold, rough ocean. But during the Ice Age, when vast quantities of water were locked up in glaciers, sea levels dropped by over 300 feet. The Bering Strait became the Bering Land Bridge, a vast plain of grassland and tundra connecting Siberia and Alaska. This is where traditional models of American colonization focused. People following Ice Age megafauna, mastodons, giant bison, saber-toothed cats, across the land bridge and down through an ice-free corridor between massive glaciers covering Canada. The timeline was neat and simple. Crossing happened around 13,000 years ago. Migrants moved rapidly south. Within a few thousand years, humans had reached the southern tip of South America, except the evidence keeps refusing to cooperate with this tidy narrative. In recent decades, archaeological sites across the Americas have been revealing human occupation that's older, sometimes much older, than the traditional model allows. Monteverde in Chile shows human occupation dating to at least 14,500 years ago, possibly 18,500. That's particularly problematic because Chile is 10,000 miles from Alaska. If people were there 18,500 years ago, they had to have crossed into the Americas much earlier. Other sites in Mexico, Brazil, and the United States push dates back even further. Some researchers argue for human presence in the Americas 30,000 years ago or more. Each new finding triggers fierce debate. Dating methods are questioned. Artifacts are reanalyzed. Alternative explanations are proposed. But the weight of evidence is slowly building toward a conclusion that would have seemed radical 20 years ago. Multiple waves of migration, different routes, coastal pathways, not just inland corridors. Some groups might have arrived by boat, hugging the Pacific coast from Asia through Alaska and down the western edges of North and South America. This would explain how people reach South American sites so quickly. They weren't walking 10,000 miles through unknown territory. They were following coastlines, using maritime skills developed from Pacific island hopping. The genetics support this complexity. Native American populations show relationships to multiple Asian source populations. Some genetic lineages connect to northern Siberian groups. Others show unexpected links to populations from southern Asia and even Australia. There's evidence of at least 4 separate migration events, possibly more, each bringing people with different genetic backgrounds and cultural traditions. What all these migrants found when they arrived was a pristine wonderland. The Americas had never been hunted by human predators. Mammoths, mastodons, giant ground sloths, enormous beavers the size of bears, horses, camels, all of them had evolved with no fear of human hunting strategies. Archaeological sites from this period show evidence of incredibly successful hunting. Multiple mammoths killed at single locations, processing sites where entire herds of animals were butchered. And like in Australia, the megafauna didn't last long after humans arrived. Between 13,000 and 10,000 years ago, North America lost about 70% of its large mammal species. South America lost about 80%. Mammoths, mastodons, giant ground sloths, saber-toothed cats, short-faced bears, dire wolves, dozens of species that had thrived for millions of years all went extinct within a few thousand years of human arrival. Again, the debate rages. Climate change was happening simultaneously. The Ice Age was ending, temperatures were rising, habitats were changing. But the correlation between human arrival and megafauna extinction is striking. It happened in Australia, it happened in the Americas, it would later happen in Madagascar and New Zealand. Wherever humans arrived for the first time, large naive animals soon disappeared. This wasn't because early humans were uniquely destructive or short-sighted. They were just doing what they had been selected to do during the bottleneck: exploit resources efficiently, adapt quickly, survive at all costs. The problem was that these animals had no evolutionary experience with human hunting strategies. They didn't know to be afraid. By the time natural selection could have taught them defensive behaviors, it was too late. Populations were too small, too fragmented. The extinction cascade had begun. But while the megafauna were disappearing, human populations were exploding. The Americas offered enormous territories with relatively few people competing for them. Groups could spread out, occupy vast ranges, develop distinct cultures in relative isolation. Within a few thousand years, humans had adapted to every environment the Western Hemisphere offered. Arctic tundra in northern Alaska and Canada, where people developed sophisticated cold-weather technologies and hunting strategies focused on seals, walrus, and whales. Temperate forests in eastern North America, where abundant game and plant resources supported growing populations. Great Plains, where nomadic groups followed vast bison herds. Deserts in the southwest, where people learned to exploit scarce water sources and developed drought-resistant crops. Tropical rainforests in Central and South America, where groups mastered the complex ecology of one of Earth's most biodiverse environments. The high Andes, where people adapted to extreme altitudes, thin air, and temperature extremes. Each environment demanded different survival strategies, different technologies, different social organizations, and because the Americas are so vast and groups were so spread out, these different populations developed in relative isolation for thousands of years. Languages diverged. By the time Europeans arrived in the 1500s, Native Americans spoke over 1,000 distinct languages from dozens of unrelated language families. Technology specialized. Arctic peoples became master marine mammal hunters. Great Plains groups developed sophisticated strategies for hunting bison on foot, long before horses were reintroduced from Europe. Southwestern peoples became expert farmers in marginal environments. Amazonian groups cultivated thousands of useful plant species in what seemed like wilderness, but was actually carefully managed forest. Cultures diversified. Some groups remained nomadic hunter-gatherers, others developed permanent villages, some created complex hierarchical societies, others maintained egalitarian bands, religious beliefs, art styles, social customs, all flourished in hundreds of different forms. But they all shared something fundamental. They were all descendants of those original migrants who had crossed into a new hemisphere. They all carried the genetic legacy of the bottleneck survivors, that chromosomal fusion marking them as human, the reduced genetic diversity that came from being descended from a tiny population that had nearly gone extinct, the cognitive adaptations that had been selected for during 117,000 years of crisis. And they all shared that drive to explore, to adapt, to survive in whatever environment they encountered. From the Arctic to Tierra del Fuego, from Pacific coasts to Caribbean islands, human populations had proven they could thrive anywhere. They could modify their technologies, their diets, their social systems, whatever it took to make a living in new environments. By 10,000 years ago, modern humans had achieved something unprecedented in the history of complex life on Earth. They had colonized every continent except Antarctica. They had adapted to every major ecosystem, from tropical rainforest to frozen tundra, from coastal marshes to high-altitude plateaus, from temperate grasslands to arid deserts. They had crossed oceans, scaled mountains, traversed deserts. They had encountered and outlasted their evolutionary cousins, and they had done it all in less than 60,000 years. To put that in perspective, it had taken their ancestors millions of years to spread across Africa. It had taken hundreds of thousands of years for earlier human species to colonize Europe and Asia. But modern humans, products of the bottleneck, had circled the globe in a tiny fraction of that time, not because they were biologically superior in simple ways like strength or speed, but because they had been shaped by near extinction into something uniquely adaptable. They could innovate new technologies rapidly when circumstances changed. They could modify social systems to handle new challenges. They could learn from each other and from their environment. They could look at an obstacle, whether it was open ocean, frozen wasteland, or trackless desert, and figure out a way across it. The world was filling up with humans. Millions of them now, speaking hundreds of languages, practicing thousands of distinct cultural traditions, but all of them, from Australian Aboriginals to Pacific Islanders to Native Americans to Africans to Asians to Europeans, all of them traced their ancestry back through that same narrow bottleneck. All of them carried the genetic signature of those untold survivors who had refused to give up when survival seemed impossible. The greatest journey in human history was nearly complete, and the world would never be the same again. So let's talk about what it was actually like to live during this period. Not the grand sweeping narratives of species expansion and technological innovation, but the daily reality of being human 40,000 years ago. What did you eat? How did you stay warm? What killed you? And what made life worth living? Because the truth is, Ice Age humans weren't just surviving, they were building lives, raising families, creating art, telling stories, laughing around fires. They were fully human in every way that mattered, and understanding their daily existence tells us more about who we are than any amount of genetic analysis ever could. Let's start with food, because everything in Ice Age life revolved around getting enough calories to survive. The humans who spread across Eurasia during the Ice Age were entering a world of incredible abundance, if you knew how to exploit it. These weren't the depleted ecosystems that modern humans inherited. This was peak megafauna territory. Europe and Asia were populated by creatures that would seem fantastical today. Woolly mammoths standing 13 feet tall at the shoulder, giant ground sloths, cave bears that weighed over a ton, woolly rhinoceroses, giant, elk with antlers spanning 12 feet, herds of horses, bison and reindeer so vast they darkened the landscape when they migrated. For Ice Age humans, these animals weren't just food sources, they were walking resource packages. A single mammoth could provide several tons of meat, enough to feed a band of 30 people for months if preserved properly. The hide could be used for shelter construction or warm clothing. The bones became tools, tent supports, and fuel for fires when wood was scarce. The fat rendered into oil for lamps that could light caves through long winter nights. The sinews became cordage stronger than any plant fibre. But killing a mammoth wasn't simple. These were intelligent, dangerous animals that could easily kill a human with a single blow. The hunt required planning, coordination, and sophisticated tactics that tell us volumes about Ice Age social organisation. Archaeological sites across Europe show evidence of systematic hunting strategies that would make modern military tacticians proud. Groups would scout mammoth movements for days, learning their patterns, identifying vulnerable individuals. Older animals or juveniles separated from the herd were preferred targets. Then they would set up the kill zone. Sometimes this meant driving animals toward cliffs or into box canyons where escape was impossible. Other sites show evidence of pit traps covered with branches, designed to immobilize large animals so hunters could finish them safely. The actual kill required multiple hunters working in perfect coordination. Some would approach from upwind, staying hidden until the critical moment. Others would position themselves along escape routes. When everyone was ready, they would launch their attack simultaneously. Spears thrown from multiple angles, coordinated movements to confuse and tire the animal, constant pressure until blood loss and exhaustion brought the mammoth down. This wasn't opportunistic scavenging. This was warfare against prey, and it required a level of communication and social coordination that only humans possessed. But mammoth hunting was the high-risk, high-reward strategy. Most days, Ice Age humans ate much more modest fare. Archaeological excavations of living sites show an incredibly diverse diet. Fish bones are everywhere, evidence that rivers and lakes provided reliable protein. Not just large fish either. These people were catching everything from salmon to eels, using sophisticated traps, nets, and hooks carved from bone. Shellfish middens along ancient coastlines show massive consumption of mollusks, mussels, oysters, clams. Modern people often think of shellfish as a delicacy, but for Ice Age humans, they were reliable calories that required minimal effort to collect. A few hours gathering along a beach could provide a day's worth of food for an entire family. They were also eating birds, eggs during nesting season, turtles, snakes, pretty much anything that moved slowly enough to catch. The bone assemblages from Ice Age sites look like modern Chinese markets. If it had meat on it, humans figured out how to eat it. Plant foods were equally important, especially during warmer months. Roots, tubers, nuts, berries, wild grains. The real skill wasn't just finding these resources, but knowing when and where they'd be available. Ice Age humans developed encyclopedic knowledge of their territories. They knew which hillsides got sun first in spring and would have the earliest shoots. They knew which caves stayed above freezing in winter and could support edible fungi. They understood seasonal patterns well enough to return to specific locations year after year at exactly the right time to harvest particular resources. This knowledge was passed down through generations, probably through stories and songs that encoded practical information in memorable forms. Your grandmother didn't just tell you to check the south-facing valley in early spring. She told you the story of how ancestor Kaa found life-saving roots there during the Great Hunger, making it a narrative you'd remember and teach your own grandchildren. But knowing where food was didn't make gathering it safe or easy. Ice Age humans lived in a world where they weren't always the apex predator. Cave lions, larger than modern African lions, hunted the same territories. Cave bears, massive and aggressive, competed for shelter sites. Saber-toothed cats, though rare by this period, still existed in some regions. Packs of dire wolves hunted cooperatively just like humans did. Every time you left the safety of your camp, you were entering an environment where something might be hunting you. The skeletal remains from this period tell brutal stories. Bones bearing the marks of predator attacks, evidence of infections that followed animal bites, injuries from hunting accidents that never properly healed. Ice Age life was dangerous in ways modern humans can barely imagine, and that danger shaped social organization in fundamental ways. Ice Age humans lived in bands, extended family groups that typically numbered between 25 and 50 individuals. This wasn't arbitrary. Groups smaller than 25 struggled to accomplish tasks that required multiple people, like driving game during hunts or maintaining fires constantly. Groups larger than 50 had trouble finding enough food in one area and faced increasing social conflicts as too many personalities tried to coexist in tight quarters. Within these bands, everyone had roles, but those roles weren't as rigidly defined as we once thought. The old idea that men hunted while women gathered turns out to be oversimplified. Recent archaeological analysis of burial sites shows both men and women buried with hunting weapons. Skeletal stress markers indicating repetitive spear throwing show up in both sexes. What seems to have actually happened is more flexible. During large communal hunts, everyone participated who was physically capable. During daily subsistence activities, people did whatever needed doing. The division wasn't strictly by gender, but by capability, experience, and immediate necessity. What was important was cooperation. Ice Age bands survived through mutual support that went far beyond simple family ties. They shared food systematically, not just within immediate families, but across the entire band. Archaeological sites show communal cooking areas where large animals were processed and distributed. This wasn't generosity. It was insurance. Today I bring down a deer and share it with the band. Tomorrow, when I come back empty-handed, someone else shares their catch with me. Over time, everyone benefits from this reciprocal altruism. They also cooperated in childcare. Ice Age childhood was long, probably as long as in modern humans. Children didn't reach full physical maturity until their late teens. That's 15 years or more when they consumed resources but couldn't fully contribute. No single family could bear that burden alone in a subsistence economy. So childcare became communal. Your children were watched and taught by the entire band. Aunts, uncles, grandparents, even unrelated adults all participated in raising the next generation. This created incredibly strong social bonds. You didn't just know your blood relatives. You knew everyone in your band intimately. You had shared experiences going back to childhood. You trusted these people with your life because you'd been trusting them your entire existence. But bands weren't isolated. They formed networks. Several times a year, multiple bands would gather at traditional meeting places. River confluences, mountain passes, coastal areas rich in seasonal resources. These gatherings served multiple purposes. They were trading events where bands exchanged resources and raw materials. Coastal bands might trade shells and fish oil for inland flint and furs. Groups from different territories would share information about game movements, weather patterns, and dangers. Most importantly, these gatherings were marriage markets. Ice Age bands practiced exogamy, marrying outside your immediate group. This wasn't just cultural preference. It was genetic necessity. Bands were small enough that without regular genetic exchange, inbreeding would quickly become a problem. So these seasonal gatherings were where young people met potential partners from other bands, where alliances were formed between groups, where the social fabric that connected distant communities was maintained and reinforced. The archaeological evidence for these gatherings is subtle but unmistakable. Sites that show sudden spikes in population, areas where raw materials from hundreds of miles away all show up together. Locations that were used repeatedly over thousands of years, becoming traditional meeting grounds. And at these gatherings, humans did something that set them apart from every other species on Earth. They created art. The cave paintings of Ice Age, Europe, are some of the most haunting human creations ever made. Lascaux, Chauvet, Altamira. Images of animals rendered with such skill and accuracy they could have been painted yesterday instead of 30,000 years ago. Horses mid-gallop, their muscles captured in flowing lines. Bison charging, heads lowered, conveying raw power in ochre and charcoal. Lions stalking, mammoths in profile, even rhinoceroses and bears. But these weren't just pretty pictures. They were something more profound. Recent analysis of cave art placement shows it wasn't random. Paintings appear in specific acoustic chambers, places where sound resonates and echoes. There's evidence of musical instruments, bone flutes capable of playing complex melodies. Hand stencils appear on walls in clusters, suggesting group participation. The paintings aren't just in easy-to-reach places. Many are in deep cave systems, requiring hours of crawling through dangerous passages to reach. What archaeologists now think is that these caves were sacred spaces, places where Ice Age humans went to perform rituals, tell stories, connect with something larger than daily survival. The paintings might have been aids to storytelling, visual references, while shamans recounted the histories and mythologies of their people. The acoustic properties suggest singing or chanting, religious experiences that combined visual art with music and narrative. The Venus figurines scattered across Ice Age Europe and Asia support this interpretation. These small carved figures, usually depicting women with exaggerated sexual characteristics, aren't crude pornography. They're religious objects. Many show evidence of being carried for long periods, their features worn smooth by handling. They appear in burial sites and in what seem to be domestic shrines. They probably represented fertility, life force, the continuation of the band through successful reproduction. And speaking of burials, Ice Age humans buried their dead with care that suggests complex beliefs about death and perhaps an afterlife. The earliest modern human burials show bodies placed in specific positions, often on their sides in sleeping postures. Grave goods appear, items placed with the deceased for reasons we can only speculate about. Stone tools, ochre pigments, animal bones, shell ornaments. One famous burial, the Red Lady of Paverland, turned out to be a young man buried 33,000 years ago, wearing ivory jewellery and covered in red ochre. The grave goods suggest high social status, possibly a leader or shaman. Some burials show evidence of flower pollens, suggesting bodies were covered with plants before burial. Others contain children interred with elaborate grave goods, indicating these weren't just beloved individuals but members of communities that valued them enough to sacrifice valuable resources. What this tells us is that Ice Age humans had developed symbolic thinking about death. They conceived of the deceased as continuing in some form. They believed that items placed in graves would accompany or assist the dead. They performed rituals that suggested grief, memory, and possibly hope for reunion. They were fully modern humans psychologically, not just in brain size or tool use, but in emotional and spiritual complexity. But spirituality didn't protect them from the harsh realities of Ice Age mortality. Infant mortality was catastrophic by modern standards. Skeletal evidence suggests perhaps 40% of children died before age 5. Childhood diseases that we prevent with vaccines were death sentences. Infections killed quickly and inevitably. Diarrheal diseases from contaminated food or water could dehydrate a child in days. Respiratory infections during cold winters claimed countless lives. Adults fared somewhat better, but not by much. The average life expectancy was probably around 35 years. Not because people couldn't live longer, many did, but because so many died young that the average stayed low. Hunting accidents, predator attacks, infections from minor wounds that turned septic. A broken leg could be a death sentence if it didn't heal properly. Dental infections could spread to the bloodstream, causing fatal sepsis. Archaeological remains show evidence of trauma that would make modern emergency room doctors wince. Healed fractures that set incorrectly, leaving people with permanent disabilities. Arthritis so severe it must have made every movement agony. Where patterns on teeth suggesting people used their mouths as tools, holding hides while scraping them, wearing down enamel until infections reach the pulp. But they also show evidence of compassion. Individuals who survived injuries that should have been fatal, which means others cared for them during recovery. A man from Shanidar Cave in Iraq lived for years after losing the use of one arm, his teeth, and probably one eye. He couldn't have hunted or gathered effectively. The only way he survived was through support from his band. They kept him alive because he was one of them, because his knowledge and experience had value even if his body was broken. We also see evidence of violence between groups, not constant warfare, but episodic conflicts that left their marks in the archaeological record. Skulls showing trauma from club blows, bodies buried hastily without grave goods, suggesting they were enemies or deaths in raids, sites that were burned and abandoned suddenly, fortified camps with defensive ditches, competition for resources sometimes turned violent when groups encountered each other in disputed territories. But this violence seems to have been the exception rather than the rule. Most sites show evidence of exchange rather than conflict. The genetic evidence of interbreeding between groups indicates cooperation was at least as common as violence, and cooperation required communication. This is where storytelling enters the picture, not just as entertainment, but as technology as important as stone, tools, or fire. Ice Age humans lived in a world without writing. Everything they knew had to be remembered and passed down orally. the locations of water sources, the migration patterns of prey animals, the medicinal properties of plants, the boundaries of allied territories. All of this was encoded in stories, but stories do something more than transmit information. They create identity. They bind groups together through shared narratives. When your band sat around the fire at night, exhausted from the day's labour, and the elders began telling the old stories, you were participating in something profound. You were learning who your people were, where you came from, what values you should hold, how to be human in the way your ancestors had been human. The stories probably mixed practical knowledge with mythology, tales of great hunts that also taught tracking techniques, stories of ancestral heroes that encoded information about territorial boundaries and relationships with neighbouring bands, myths that explained natural phenomena while teaching children about dangers and opportunities in their environment. Music accompanied the stories. Those bone flutes weren't just for cave rituals. They were everyday instruments that made hard work more bearable and celebrations more joyous. Rhythm and melody helped people coordinate their movements during communal tasks. Songs probably accompanied nearly every group activity, from hide processing to tool making to simply walking between camps. And through all of this, through the danger and hardship and loss and violence, Ice Age humans were doing something remarkable. They were living full lives. They weren't just surviving. They were experiencing joy, love, friendship, wonder. They looked at the night sky and felt awe. They held their children and felt fierce protective love. They mourned their dead and felt grief. They celebrated successful hunts and felt pride and satisfaction. The archaeological record captures only fragments of these inner lives, but we know they existed because we experience the same emotions today. Because the humans who painted those cave walls and carved those Venus figurines and buried their dead with flowers were us, genetically, neurologically, emotionally identical to modern humans. They just happened to live in a world where staying alive required knowledge, strength, cooperation, and sheer determination that few modern humans could match. Where a single mistake could mean death, where winter wasn't an inconvenience but a life-threatening ordeal, where food security was never guaranteed and danger was always present. And yet they didn't just survive that world, they mastered it. They spread across entire continents, they raised families and created art and told stories and laughed and loved and grieved and hoped. They were our ancestors, and every human alive today carries the genetic signature of their success. The adaptations that let them thrive in Ice Age. Landscapes are still written in our DNA. The social structures they developed are still the foundation of human communities. The artistic traditions they pioneered still inspire us today. When you look at cave paintings in museums or photographs, you're not looking at the work of primitive savages barely more advanced than animals. You're looking at the creations of people who are exactly as human as you are, who faced a world far more challenging than anything modern humans encounter, and who not only survived but created beauty and meaning and left a legacy that stretches unbroken across 40,000 years. That's the real story of life and death in the Ice Age. Not just survival, but humanity. Full, complete, complex humanity expressed under the most difficult circumstances imaginable. And everything we are today, all our achievements and societies and dreams, grew from the seeds they planted during those frozen millennia when being human meant something raw and immediate and profound that we've almost forgotten. So here we are, 300,000 years after modern humans first evolved, 70,000 years after we left Africa, 30,000 years after we became the last human species standing, 7 billion of us scattered across every landmass on Earth, speaking 7,000 languages, practicing 10,000 different ways of being human. What do those ancient journeys have to do with us today? Everything. Those migrations didn't just spread humans across the planet, they made us who we are, literally. The choices our ancestors made, the environments they encountered, the other humans they met and sometimes mated with, all of it is written into our bodies, our minds, our DNA. Let's start with the most obvious legacy, your physical appearance. The way you look right now reading this is a direct result of where your ancestors travelled and what they encountered when they got there. Take skin colour. This is probably the most visible human variation, and it's entirely about those ancient migrations. When modern humans lived exclusively in Africa, they had dark skin. High melanin production protected against intense UV radiation near the equator. This wasn't just cosmetic. Too much UV exposure destroys folate, a vitamin crucial for reproduction and fetal development. Dark skin was literally a matter of survival. But when human populations migrated north into Europe and Asia, they encountered a completely different selective pressure, less intense sunlight. Suddenly, dark skin became a disadvantage. Melanin blocks UV radiation, but humans need some UV exposure to produce vitamin D. In northern latitudes with less sunlight, especially during long winters, people with very dark skin couldn't produce enough vitamin D. Vitamin D deficiency causes rickets, a disease that deforms bones and can make childbirth deadly for women, so natural selection favoured lighter skin in northern populations. Not immediately. This took thousands of generations, but eventually European and Northern Asian populations evolved significantly reduced melanin production. The genetic mutations that cause light skin are relatively recent. Some only became widespread in the last 10,000 years. This means your skin colour is one of the most recent evolutionary adaptations in human history, and it's a direct map of where your ancestors migrated. Dark skin near the equator, light skin in the north, intermediate shades in between. Your body is wearing a genetic map of ancient journeys. Eye colour works similarly. Brown eyes are the ancestral human trait. We all had brown eyes in Africa, but populations that migrated to northern Europe developed a mutation that reduces melanin production in the iris. Blue, green and grey eyes are all recent evolutionary developments, probably appearing within the last 10,000 years. If you have blue eyes, your ancestors were almost certainly part of the European migration, and that genetic variant can be traced back to a single individual who lived near the Black Sea. Hair texture is another migration marker. Tightly curled hair, like dark skin, is protective in hot climates. It creates an insulating layer of air above the scalp that helps regulate temperature and protects against UV damage. But in colder climates, this advantage disappears. Populations in northern regions evolved straighter hair, while those who remained in tropical areas maintained the ancestral curly hair type. Again, your hair is telling the story of where your ancestors travelled. Body proportions show the same patterns. Remember how Neanderthals evolved robust builds for Ice Age Europe? Modern human populations show similar adaptations, though less extreme. People whose ancestors lived in cold climates for thousands of years tend to have stockier builds, shorter limbs relative to torso length. This is basic physics. Compact bodies have less surface area relative to mass, which means less heat loss. Populations in tropical regions show the opposite pattern. Taller, more slender builds with longer limbs. More surface area means more efficient cooling through sweating. Some of the tallest, most slender people in the world are East African populations who never left the ancestral homeland. Some of the stockiest builds are found in Arctic populations who migrated to the coldest extremes. These aren't just interesting variations, they're proof that human evolution didn't stop when we left Africa. We continued adapting to local environments for tens of thousands of years, and we're still evolving today. But the most profound legacy of these ancient migrations is invisible. It's in our DNA, in patterns of genetic diversity that tell stories of bottlenecks, founder effects, and ancient encounters with other human species. Here's something that surprises most people. Despite spreading across the entire planet and adapting to radically different environments, humans are remarkably genetically uniform. Compared to most other species, we have very low genetic diversity. Two humans from opposite sides of the planet are more genetically similar than two chimpanzees from neighbouring troops in the same forest. This goes back to the bottleneck. That 117,000-year near extinction event eliminated most human genetic variation. When the population finally recovered and expanded, all modern humans descended from that tiny surviving group. We're all incredibly closely related. But here's where it gets interesting. The genetic diversity we do have shows clear geographic patterns that map directly onto those ancient migrations. And the patterns tell us exactly how humans spread across the planet. The highest genetic diversity in the world is found in Africa, specifically in populations that still live near the regions where modern humans first evolved. San people of southern Africa, for example, show more genetic variation within their population than exists in all of Europe, Asia, and the Americas combined. This is exactly what you'd expect if modern humans originated in Africa, and then small groups migrated outward. The homeland population retained the most genetic diversity. Each migrating group carried only a subset of that diversity, creating what geneticists call founder effects. Think of it like this. Imagine you have a jar containing 10,000 different coloured marbles. That's the African population maximum genetic diversity. Now you reach in and grab a handful, maybe 100 marbles. That's your migrating population. Those 100 marbles won't represent all 10,000 colours. They're a sample, and they've lost most of the original diversity just through random chance. Then your handful of 100 different coloured marbles becomes the starting population for a new region. All the genetic diversity in that region will come from just those 100 marbles. You can never have more variety than you started with. In fact, you'll probably have less because some colours will get lost along the way. That's a founder effect, and it happened repeatedly as humans migrated around the planet. The genetic data shows this pattern perfectly. European populations have less genetic diversity than Middle Eastern populations. East Asian populations have roughly similar diversity to Europeans, but with different genetic variants. Native American populations have even less diversity, consistent with them being founded by a small group that crossed from Asia into the Americas. Pacific Islander populations show the most extreme founder effects. Polynesian groups who sailed to remote islands like Hawaii, Easter Island, and New Zealand descended from incredibly small founding populations, sometimes just a few dozen individuals. Their genetic diversity is correspondingly limited. This matters for practical reasons today. Certain genetic diseases are more common in some populations than others, not because of anything inherent to those populations, but because of founder effects and genetic drift over thousands of years. Understanding these patterns helps medical researchers develop better treatments and identify genetic risk factors. But the really exciting discoveries have come from ancient DNA. In the last 15 years, scientists have developed techniques to extract and sequence DNA from bones tens of thousands of years old, and what they've found has revolutionized our understanding of human history. Remember how I said everyone of non-African descent carries about 2% Neanderthal DNA? That was discovered through ancient DNA analysis. Scientists sequenced the Neanderthal genome and compared it to modern human genomes. The overlap was unmistakable. Our ancestors had interbred with Neanderthals and were still carrying their genes. But it gets more interesting. Those Neanderthal gene variants aren't random. They're clustered in parts of our genome that affect specific traits. Some Neanderthal genes help with immune function. We literally inherited parts of our immune system from Neanderthals. ready-made adaptations to European diseases that modern humans would otherwise have taken thousands of years to evolve resistance to. Other Neanderthal genes affect skin and hair. Some of the genetic variants that cause red hair and fair skin in Europeans came from Neanderthals. They had already evolved these adaptations for low-light environments. When modern humans arrived in Europe and interbred with Neanderthals, we picked up these useful traits through hybridization. Denisovan DNA shows up in similar patterns. East Asian populations carry small amounts of Denisovan DNA, but Pacific Islanders carry much more, some as high as 6%. And some of these Denisovan genes are still providing survival advantages today. Remember those Denisovan genetic variants that help process oxygen at high altitude. They're still functioning in modern Tibetan populations, allowing people to live comfortably at elevations that would incapacitate most humans. There's another Denisovan gene variant found in some Pacific Island populations that affect body fat distribution. It appears to be an adaptation to traditional maritime lifestyles, helping with buoyancy and temperature regulation during long periods in water. Ancient interbreeding gave modern humans ready-made adaptations for island life. But here's what's really profound. These encounters with other human species didn't just give us useful genes. They gave us a more robust genetic toolkit overall. Interbreeding increased genetic diversity in the migrating populations that had lost diversity through founder effects. It's like our ancestors found genetic treasure chests left by their evolutionary cousins, and they grabbed everything useful. This challenges old ideas about human evolution. We used to think species were distinct, separate, competing for dominance. The reality was much messier and more interesting. Different human species encountering each other didn't just fight. They sometimes cooperated, formed relationships, had children together. The boundaries between species were porous. We're not purely one thing, we're a blend. The product of multiple human lineages coming together. Every person outside Africa is part Neanderthal. Many Asians are part Denisovan. We're all hybrids, carrying the legacy of multiple human species in our DNA. Recent discoveries keep adding complications to this story. In 2019, scientists announced they'd found a bone fragment from a teenage girl who lived 90,000 years ago. DNA analysis revealed she was a first-generation hybrid. Her mother was Neanderthal. Her father was Denisovan. Two different human species had met, formed a relationship, and had a child. And we found her. Other discoveries suggest there may have been additional human species we haven't even identified yet. Some African populations carry genetic variants that don't match any known human lineage, suggesting interbreeding with an unknown archaic human species that lived in Africa. We're calling them ghost populations because they've left genetic evidence, but no fossils we've identified yet. In Asia, some genetic patterns suggest encounters with another unknown human species, different from Denisovans. The DNA evidence is there, but we don't know who they were or what happened to them. The story keeps getting more complex. Every new ancient DNA sample, every new fossil find, reveals another chapter we didn't know existed. Human evolution wasn't a simple tree with clearly defined branches. It was a braided river, multiple streams flowing separately but occasionally merging, exchanging genetic material, splitting apart again. This has profound implications for how we understand human diversity today. The physical and genetic differences between human populations aren't ancient divisions. They're recent adaptations to local environments, combined with small amounts of DNA from encounters with other human species. We're not separate races with deep biological distinctions. We're one incredibly young species that underwent a severe genetic bottleneck, then rapidly expanded and adapted to different environments over just a few thousand generations. There hasn't been enough time for significant genetic divergence between populations, The differences we see are surface-level adaptations that evolved quickly because they provided immediate survival advantages. Understanding this matters. For centuries, people have used superficial physical differences to justify treating other human populations as fundamentally different or inferior. But genetics tells us unequivocally that these ideas are scientifically baseless. All modern humans are descended from the same small bottleneck population. We share 99.9% of our DNA with every other human on Earth. Those ancient migrations didn't create separate human types. They created a single human species with superficial adaptations to local environments. We're all African in origin. We're all carrying Neanderthal genes if our ancestors left Africa. We're all the product of the same evolutionary pressures and the same ancient journeys. But those journeys also gave us something else: cultural diversity. As human populations spread across the planet and adapted to different environments, they developed thousands of different ways of being human. Different languages, different technologies, different social structures, different ways of understanding the world. Linguists have traced language families back through time, constructing family trees that mirror the genetic evidence of human migrations. The languages spoken today in Europe, Iran, and India all descended from a common ancestral language called Proto-Indo-European, probably spoken around 6,000 years ago by populations living north of the Black Sea. Chinese, Japanese, Korean, and many Southeast Asian languages form different family trees, reflecting the independent migrations and developments of Asian populations. Native American languages show patterns consistent with people crossing from Asia in multiple waves over thousands of years. African languages show the most diversity, just like African genetics. Thousands of distinct languages, some as different from each other as English is from Chinese, all spoken within a single continent. This reflects both Africa's role as humanity's homeland and the fact that African populations had more time to develop linguistic diversity. Some of our most fundamental human capabilities, our ability to learn language, to transmit culture, to cooperate in large groups, were forged during those ancient migrations. Small groups travelling into unknown territories needed better communication to survive. They needed to share knowledge quickly and accurately. They needed to maintain relationships across distances. These pressures refined human cognitive abilities. The people who survived those journeys were the ones who could adapt quickly, learn new skills, communicate effectively, and work together to solve unprecedented challenges. We inherited those capabilities. They're what allow modern humans to live everywhere from Arctic tundra to tropical rainforests to orbiting space stations. But we've also inherited the vulnerabilities. Remember those founder effects and bottlenecks? They didn't just reduce genetic diversity. They increased our susceptibility to certain genetic diseases. Small populations going through bottlenecks accumulate harmful mutations that would normally be eliminated by natural selection in larger populations. This is why some genetic diseases are more common in certain populations. Tay-Sachs disease in Ashkenazi Jewish populations, sickle cell anemia in populations from malarial regions, cystic fibrosis in northern European populations. These aren't because these populations are inherently weaker. They're the result of founder effects, bottlenecks, and in some cases mutations that provided advantages in certain environments, but caused problems when carried in two copies. Understanding this helps us develop better medical treatments and genetic screening programs. It also reminds us that human genetic diversity, limited as it is precious. Every population carries unique genetic variants that might prove valuable in the future. When populations go extinct or are absorbed into others, we lose genetic diversity that took thousands of years to develop. The legacy of those ancient journeys is also visible in how we think about ourselves. the human tendency to identify with groups, to see the world as us versus them, probably evolved during those migrations. Small groups travelling through dangerous territories needed strong internal cohesion. They needed to trust and cooperate with group members while being wary of outsiders who might compete for the same resources. This served us well for hundreds of thousands of years. But in today's interconnected world, it creates problems. We still tend to categorize people by appearance, language, and culture. Despite knowing these differences are superficial, we're running software evolved for small group cooperation in a world that requires global cooperation. But here's the hopeful part. We also inherited the capacity for innovation, flexibility, and cultural exchange that allowed our ancestors to thrive. Modern humans succeeded not because we were the strongest or the fastest or even the smartest. We succeeded because we could adapt, learn, and work together. Today we face challenges our ancestors couldn't have imagined. Climate change, global pandemics, resource depletion, nuclear weapons. These threats require cooperation on scales far beyond anything humans evolved for. But the same qualities that carried our ancestors through the bottleneck and around the planet give us hope. We can adapt. We can innovate. We can cooperate when survival demands it. The story of human migration is ultimately a story of resilience, a species that came within a few thousand individuals of extinction, a population that faced climates and environments that should have been impossible to survive, groups that walked into the unknown with nothing but stone tools and their wits, and not only survived but thrived. Every person alive today is descended from those survivors. We carry their genes, their adaptations, their ingenuity. When you face a challenge that seems impossible, remember, your ancestors survived the bottleneck. They walked out of Africa into an unknown world. They crossed deserts and oceans. They survived ice ages. They built the first civilizations. You carry that legacy in every cell of your body. Those ancient journeys made us who we are, adaptable, innovative, resilient, capable of incredible things when necessity demands it. The scientific mysteries remain. We're still finding new fossils, sequencing new ancient genomes, discovering new evidence of forgotten human species and unknown migrations. Every few years, a new discovery rewrites part of the story. That 900,000-year-old bottleneck I told you about? We only discovered that in 2023. The Denisovan Neanderthal hybrid girl, 2019. Evidence of humans in the Americas earlier than we thought, just discovered in the last few years. The story of human origins and migrations is still being written, but what we know so far is extraordinary, and it all connects back to you, right now, wherever you are. You are the product of the greatest journey ever told, and that journey isn't over yet, so here we are. The end of the greatest journey ever told. From a population of 1,280 survivors huddled in small groups across Africa, clinging to existence through 117,000 years of environmental hell, to 8 billion people spread across every continent, living in cities that would seem like magic to our ancient ancestors. That's what happened to the early humans who left Africa. They survived. They adapted. They thrived. They encountered their evolutionary cousins and sometimes fought them, sometimes loved them, sometimes both. They crossed deserts that would kill modern explorers in days. They navigated open oceans in boats we can barely imagine. They walked across ice sheets a mile thick and hunted animals that could crush them with a single blow. And they won. Not because they were the strongest. Neanderthals were stronger. Not because they were perfectly adapted to any particular environment. Denisovans had already claimed those specialized niches. They won because they were flexible, adaptable, capable of looking at impossible challenges and figuring out solutions that had never been tried before. Every technological innovation we discussed, from hafted spears to sewn clothing to boat building, represents someone having an idea that had never been thought before, someone looking at a problem and imagining a solution that didn't yet exist. That's the real legacy of the bottleneck, not just survival, but the capacity for endless innovation. Think about what that means. Your ancestors, whoever you are, wherever you're watching this from, survived a population bottleneck that reduced humanity to its absolute minimum viable number. They survived ice ages that lasted tens of thousands of years. They crossed oceans before they had compasses or maps. They settled in rainforests, mountains, deserts, tundra, islands, every possible environment this planet could throw at them. And they did it with stone tools, with fire, with nothing but their intelligence, their cooperation, and their stubborn refusal to give up when things got hard. The DNA evidence tells us that everyone outside Africa carries Neanderthal genes. Everyone with Asian or Pacific ancestry carries Denisovan genes. We're all walking testaments to those ancient encounters, to the moments when our ancestors met other human species and chose connection over conflict. At least sometimes. But more than that, we're all carrying the genetic signature of the bottleneck, that chromosomal fusion that marked our species 900,000 years ago, the neural adaptations that were selected for during those desperate millennia. The capacity for language, for symbolic thinking, for technological innovation that allowed our ancestors to not just survive, but to remake the world in their image. When you're sitting in traffic frustrated about being late to work, you're using cognitive abilities that were refined during Ice Age hunts. When you're navigating complex social relationships at work or school, you're drawing on social intelligence that evolved to maintain kinship networks across vast distances. When you're learning a new skill from a YouTube video, you're exercising the same cultural learning abilities that allowed stone tool techniques to spread across continents. The archaeological record shows us the physical remains of this journey. Stone tools scattered across migration routes, cave paintings that mark the emergence of symbolic thought, burial sites that reveal increasingly complex spiritual beliefs. But the real story is written in our DNA and in our behavior. We are the species that survived the unsurvivable, the population that bounced back from the very edge of extinction, the descendants of people who looked at frozen wastelands and open oceans and endless deserts and decided to cross them anyway. That's not just history, that's heritage, your heritage, regardless of where you're from or what you look like. Because all modern humans trace back to that same small population of African survivors. All of us carry the legacy of their determination, their adaptability, their refusal to accept that any challenge was truly impossible. So the next time you're facing something difficult, something that seems insurmountable, remember that you come from a lineage that survived literal extinction events. You carry genes that were forged in the crucible of the worst climate disaster in human history. You possess cognitive abilities that were refined over hundreds of thousands of years of continuous adaptation to changing circumstances. The ancient footsteps that carried humanity from Africa to every corner of the globe still echo in your DNA. The curiosity that drove them to see what was beyond the next horizon lives in your mind. The courage that allowed them to venture into unknown territories facing unknown dangers beats in your heart. We are their legacy. Every achievement of modern civilization, every technology, every work of art, every scientific discovery traces back to the survival traits that were selected for during the bottleneck and refined during the great migrations that followed. The early humans who left Africa didn't just survive, they created us. Everything we are, everything we've accomplished, everything we're capable of becoming, started with those ancient travellers who looked at an unknown world and decided to explore it. That's what happened to them. They became us. If this journey through deep time has resonated with you, hit that like button. Drop a comment letting me know where you're listening from, what part of the world your ancestors helped settle, and subscribe if you want more stories about the incredible history written in our genes and scattered across the archaeological record. Because this is your story, our story, the story of the species that refused to die. Sleep well, knowing you carry the echo of ancient footsteps in every cell of your body.